We've done a lot with our recursive sequences thus far, and now we're going to look at our graphs of them. And so when we graph a recursive sequence, or like our arithmetic and geometric sequence, we do so by what we call discrete graphs. It's basically kind of a scatter plot. And then we try to like model a close fit, whether it's like a line or a curved line, and we'll take a look at what those would mean in those cases. So for example, this first guy, I have an initial term, right? So when n is 0, our initial term is 8. And let's go find that on the graph. So if I look on the graph, the x-axis is always your term number. So for example, this would be your 0th term, your first term, second term, third term, so on and so forth. Right? And in this case, our initial term is the 0th term. So at the point 0, 8 is our initial term, right? Because 0, so our coordinates are kind of like n, the term number, and the value in that term number, right? So the 0th term value was 8. And then if I look, it's really doing what? Going down 2. So it keeps going down 2. So if I go 1 over, my term in the 1 spot would be 1, 6, right? It keeps going down 2 each time. So I can just look at my recursive formula and figure that out. Well, just by looking at that, can I tell if this is arithmetic or geometric? Yeah. If it's adding or subtracting, it's arithmetic, right? And if it's arithmetic, that means it's got a constant, right? It's going up or down by the exact same amount each time. So would that make this guy linear or non-linear? Would it make a straight line if I connected them? Yeah, if it's got a constant, it's going by down 2 each time, it's definitely going to make a straight line. So I can just visualize that by looking at the graph. Otherwise, I can just look at what's being added or subtracted. If it's added or subtracted, then it's linear. If it's being multiplied, then it would be nonlinear, because that's going to be exponential, and you'll see that as you work through your assignment. And the last thing you can say about this is whether it's increasing or decreasing. Well, if you have the graph, it's nice and easy. Otherwise, you can just take a look. Well, if you're subtracting, that's nice and easy. It's decreasing, right? If it's dealing with multiplication, basically if you're multiplying by something greater than 1, it's going to be increasing. If you're multiplying by something between 0 and 1, then it's going to be decreasing, right? If you multiply by a decimal. Yeah. So those are just some things you could say about it. And if I wanted to graph this on my calculator, let's take a look and see how that works. So just make sure that you're in, sequential mode. I am SEQ. Go to my equation editor. So I got mine typed in. So my 0th term, you got to have 0 up here, right? Because we're starting with 0 as your initial. And then I have u sub n minus 1, minus 2. That looks good. Initial term of 8. Perfect. Okay. So you should have a nice window for it. So if I think about this, I'm starting at 0 on my x-axis, right? And I'm going up to 10 in this case, because I'm showing about, the first 10 terms or so. So starting at 0 on my x-axis, right, because that represents the end, and I'm going up to 10. Perfect. Plot start and plot step, we can keep that at 1. That's just fine. And then for x min and x max, that should just match what you have for your ends, because that's your x-axis as well. So I'm going to go 0 and 10, perfect, minimum and maximum. X scale, well that's what it counts by. I don't want it to count by 500s, that wouldn't make any sense. So we're counting by 1s. Alright, y min, well let's take a look at my y. Go back to the graph. Yeah, I should probably go down to negative 10, because I have some points, close to negative 10. And I should go up to at least 8, so I might go up to 10 as well. So let's go back with my calculator. Negative 10, that looks good, my y minimum. And 10 for my maximum, good. And let's count by 2s instead, right? Because in this case, I'm counting by 2s. And then we can go ahead and graph that guy. So there we go. There's my nice discrete graph. And if I want to look at the points exactly, I can always hit trace, and that'll put me right in the graph. So here's my first point. 0, 8. Good, on the 0th term. There we go. First term, 1, 6. Got it. And it keeps going down 2 each time as I go. And it also puts your recursive formula up top so you can see that. Okay, fancy stuff. So let's get some good practice on how we'd set up a table if we were to graph. So in this part, in number 1, it says, suppose you're going to graph the specified terms of the sequence. For the sequence, what minimum and maximum values of n and u sub n would you use on the axes to get a good graph? Well, let me just picture this graph here. So right here, something like this. Sometimes you might go further down, sometimes you might go further left. Just know that your x-axis deals with your term number, and your y-axis deals with the value in that term. Okay, so if I want the first 20 terms of the sequence, do I just automatically go 1 through 20 for n? Would that work out? Right, terms 1 through 20? Well, be careful. What's your initial term? My initial term I'm calling the 0th term. So I don't want to start with 1. I want to start with 0. And I wouldn't go to 20 because that would give me 21 terms. So I got to drop to 19. So that would be incorrect right there. I want to start with 0 and go to 19. So if I actually made this on a graph, I wouldn't need this extra stuff on the left. I could start right with 0 and I could work to 19. You know, technically I could go to 20 if I made a table, but we're being like super specific here. And then for the use of n, you know, this one, usually you can start with 0. The only time you don't want to start with 0 is when you know you're going to have some negative numbers. Well, if I simplify my recursive formula, I have use of n equals 0.82 times use of n minus 1. So basically, if I keep multiplying the previous term by 0.82, will I ever get a negative number? No, I'll just keep getting smaller and smaller and smaller. So I could start at 0. That's a good starting point. So I could say from 0 to, well, how big? What's going to be the biggest number that I deal with? Well, if I multiply by 0.82, is this increasing or decreasing? It's going to get smaller, right? This thing is going to decrease. Decrease. And I'm starting at 400, so it's going at 400 and it's going down. So 400 should be the highest y value or use of n value that I use. So if I made this on my y-axis here, I'd probably count by, you know, hundreds would probably be fine. 100, 200, 300, 400. Something like that. And so I wouldn't really need an x or y-axis going down into the negatives. Okay, so sometimes you'll have negatives. If you do, you know, even if you jump ahead, if you would have said, you know, for your n value here, if you'd have said 0 to 20, I'd be just fine with that, okay? Because you can have your table be a little bit beyond its where the range of your data is at, or for your sequence. But we're just trying to kind of be exact in this case. So I'll be pretty lenient on this, just as long as all your data from your sequence fits on your graph. That's kind of the main key. And the other thing you do, you could actually physically put this into your calculator and take a look and adjust your table to kind of get a view. Or even look at your table. Maybe when you put it in your calculator, you can look at the first 20 terms and just see what values you would need for your y-axis, right? Whatever would be in here. In this case, it'd be like 400 to whatever here. Okay, it probably wouldn't even go all the way to 0. So that would be another way to check. All right, let's use this now. It says, consider the geometric sequence. So that means it has a common ratio, right? It's being multiplied each time. And it's got the numbers there. Write a recursive formula and sketch a graph. All right, recursive formula. Here we go. So I have u sub, well, do we want to use 1 or 0? Really, it doesn't matter all that much. If we're going to sketch a graph, we always want, you know, if we can, we want our x to start at 0. So I want my n to start at 0 as well. So I'm going to say u sub 0 for my initial term is 18. And then u sub n equals, well, in this case, am I adding or subtracting stuff on, or am I multiplying? Well, it's geometric, so you know you're multiplying. Well, how do you figure out what that common ratio is, what you're going to put with that u sub n minus 1? And we're going to take any term and divide by the term in front. Because then you'll know, remember, because we're looking at 18 times what will give me negative 13.5. So we got to work backwards, so we divide. So when I divide those two, negative 13.5 divided by 18, I believe I get negative 0.75. So it's a decimal that terminates, so I can use it. So I'm going to go negative, I like putting zeros in front of my decimals, 0.75 times u sub n minus 1. Okay, because it's geometric, so it's multiplication. And then lastly, we always say, remember, when n is greater than or equal to, remember, just look, I'm starting with the 0th term, so I always go 1 greater than that, which is 1. All right, now it says, what is the long run value? Oh, forgot to sketch graph, sorry. Okay, so let's think about what should I do? Am I going to have some negatives for my y? Yeah, I can say I have a positive, I have a negative, positive, a negative. So I know I'll have positives and negatives, so I'm going to get a line going like this. And I'm starting at 0, right? The 0th term was my first one. So I don't need anything really to the left of my x. And I can come this way. Well, can I already tell like what's my biggest y value or my biggest like use of n value is and my smallest? Sure, this one you can kind of look at and see, right? I'm starting at 18, and then it goes to negative 13.5, and then it goes to 10.125, and then it goes to negative. So the numbers are getting smaller, right? And they're just bouncing back and forth between positives and negatives. So really, I know that 18 is going to be my biggest one on the y-axis, right? Or the use of n, the value of the sequence. So really, I could probably put this at 20. I could jump a little bit ahead. And I could go down to like negative 15. So maybe I might just count my 5s. 5, 10, 15, 20. That would be a good idea, right? Because it's never going to go above 20. It's never going to go below negative 15. Well, so I could, let me just grab these first couple points. And let's do like the first 10 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to count by 1s for this guy. 8, 10. On my dashes. And I'm going to grab these ones. So I got 18 for my zeroth term. So that's like up here. I got negative 13.5 for my first term. And then I got 10.125 for my second term. And then I got negative 7.6 for my third term. And then my fourth. So if I want to keep going, I should probably put this in my calculator. And I'm going to do that so we can get a better look at our long run value. All right, so let's go back to our equation editor. So I got use of n minus 1, and we're going times, whoops, better get that in the right spot, times negative, don't hit a minus sign, use your negative, 0.75, and our first term is 18. Okay, and I'm going to go to my window, and we started at 0, went to 10, that's good. I might even bump it to 20 just so you can see some more numbers. And then I should do the same for my x, since that's also my n. And we're counting by 1s, that's fine. Y's, we went down to negative 15, so we want to be able to see our second term, okay? And we went up to 20 on our y-axis. So let's go ahead and look at this on our window. Can we tell what the long run value is? Right, as this graph continues, or it kind of keeps bouncing back and forth from negative to positive, it looks like the long run, its limit is going to be 0, right? It's going to like pretty much be right on that 0. So I know just by looking at the graph that my long run value is 0. And if I went to my table, I should also be able to tell that as well. If I pop up my table, I start scrolling down. All these numbers are working closer and closer to 0. So there we go. So you can tell by the graph or by looking at your table. And if you want to jump further ahead, you might just want to either reset your table settings, or you could go over to your home screen and type in and say, like, what's the 100th term? And it would tell me that it is, wow, a really small decimal. That's scientific notation. That's like 0.000, a bunch of them, 11 times, and then, yeah, so super small. Okay, so we're just basically using what we've learned in the last few sections to apply it to some graphs now.